20 pi by 10 radians per second. Current leads the voltage, or voltage leads the current, lags the voltage, no? Graph.
Sir, omega should be 100 pi, sir.
Milliseconds, no, it is 20 milliseconds. 20 into 10 to power of minus 3. 100 pi, yeah. Now look at graph. I think it's clearly visible, no? The current one, no? 0 you can see. So it is having a 0 phase. What about the voltage? Voltage is having positive phase. So by this time I think you're clear. If the same voltage, if I draw it, it will have negative phase. Please try to understand now the phase lead, phase lagger. I think not related. Just some information let me share, then I'll come to this problem. Suppose say if you have signals like this, so which one is lead, lag? So let me take the black color one. So this particular thing is what I'll call V1. Then I'll draw another one. I'll take another one. Let it be off like this. It's a rough, not up to the scale. Which one is leading, which one is lagging, how to mention that. So this is, I'll call V1. V2, and the red color one is V3. So V1 is having some V1 is having 0 phase, no? And what about V3? V3 leads V1. And what about V2? V2 lags V1. So how to interpret that one? V3 leads V1 and V2 lags V1. What about V3 and V3 and V2? Any relationship between them? Definitely what will happen? Which is V3? V3. That color is V3. V3 leads V1, V2 lags V2. So V3 lags V3 leads V2. That lead lag, able to understand now? If they give curve, you just take help of this condition here. If they give phasor diagram, it's okay. So can you show these things in phasor diagram? Yes, it can also be. We can also put in phasor diagram. In the phasor diagram, the representation, V1 is having 0 phase. V3 is having positive phase. So it'll come like this. Because this is 0 degree angle, no? And what about V2? V2 will come here. Justified, V2 lags V1, V3 beats V1, and V3 leads V2. If they give sinusoidal curves, this is a method. Phasor diagram, it will be much easier. Above 0, this will be. In exam, can be asked anywhere like this. Okay, come for this. So definitely what I can say now, the current lags the voltage, or voltage leads the current. Current lags the voltage means it should be RL circuit or RC circuit. RLC is telling, so we can't say RL or RC. So only reactance, what we can put it here. So altogether, can we say it's a lag circuit? Current lags the applied voltage. Current lags the applied voltage. So therefore, it's a lag circuit here. This much I can write it here. How to get things here, no? So go back to the basic idea of, we'll write expression for V. V equal to sine omega t, the voltage sine omega t plus initial that phase. At t equal to 0, what is the value of V? V will be 100. Is it, I think some of you are asking, so this is the current one. Huh? I'll draw it. Huh? Some of you are asking, sir, which is a, this is a current. Huh? Okay, let's write for voltage. So at t equals 0, what is the value of voltage? It should be 100. So it is touching here. This should be the 100. So here 100 is equal to maximum voltage is how much? You look at the graph, 400
Sir,
sine
200, sir. Maximum voltage is 200, sir.
200. Yeah. Current is that one, no? Yeah. So now with this, the phase angle will get is equal to 1 by 2 pi by 6. No, I just now told you, no, like components. So here the voltage is in phase and the current is having phase angle of this one. So here the current lags the applied voltage. So VRMS will come here. Justified. This will be, so from this circuit, what we can draw it here. This will be R. This will be reactance and this will be impedance. So again, so what is R? We know phase angle. Can we calculate the impedance of the circuit? Impedance is what? VRMS by IRMS. We know VM and we know IM also. So impedance, I can write it as VRMS by IRMS or VM by IM. Then if I know impedance, can I bring R? R is what? Z cos phi. And what about reactance? Z sin phi. And after this, what is the average power dissipated? It should be equal to or VRMS, IRMS, cos phi, any of the formulas. From graph also can be asked here. Huh? Be careful. Only reactance we are able to tell how much value of L and C, not per,